In this video I'm going to describe how to emulate a Space Invaders arcade circuit board using the C programming language. So in previous videos I've shown how to emulate computers like the Sinclair Spectrum, TRS-80, Apple II computer, but in this video I'm actually switching to emulating a circuit board for an arcade machine for Space Invaders. So I've got the emulator running here. What I'll do is I'll go through some of the emulations and the ROM sets that you can run on the Space Invaders PCB, and then I'll go over the source code and describe how it's emulated using C. So in my actual emulator itself, I've done some updates since I last did a video on emulation, and so I've got a feature where you can select ROM set. So there's different ROM sets you can run on a Space Invaders arcade PCB. So there's Alien Invasion, Earth Invasion, Space Invaders Part 2, Space Invaders Deluxe, Invaders Revenge, and Space Invaders itself. And also I've got configurations, so you saw it started up in monochrome mode because the Space Invaders PCB only outputs a monochrome signal. But on some Space Invaders machine you can actually put like a colour filter over the actual CRT itself, or on Space Invaders Deluxe I think it did it reflecting off of a mirror through a colour filter. But just all that does is give you bands of colours. So if I was just swap to that configuration, and now you can see like it comes up with the colour bands as it would on the actual arcade machine itself. So I'll go through all the ROM sets and just describe some of the differences between the ROM sets. So this is the original Space Invaders, and it's just going for its demo mode now. Also, if I press the F function keys, if I press F1, it comes up with dip switch settings. So if I just come out of there for now, if I start a game by putting a credit in and then pressing player 1 button, you can see it's got 3 bases for the actual one player game. I can actually control it and actually play the game, but in the dip switches you get on the arcade PCB, it gives you options that you can change. So if I change it to 6 bases, so if I switch on the dip switches 3 and 4, that'll give me 6 bases per game. And I come out of there and I'll just reset the emulator. Now if I do a credit and then start a game, see I've got 6 bases at the bottom. So I can actually play with six games. So different arcade PCBs give you different options on the dip switches. I'll set it back to just like the 3 base game. Oops. By switching those dip switches back off again. And the dip switches mean different things for different ROM sets. So these are the dip switch options for the actual Space Invaders PCB. But when I play something like Invaders Revenge and things, the dip switches probably mean something different for those ROM sets on the PCB. So I'll just go back to the configuration there. Okay, so if I play a game of Space Invaders, so insert a coin and then start a game, what I'll do is I'll compare the different games and how the different ROM sets differ. So this is just like the standard Space Invaders, and you just play levels of Space Invaders, and they literally just march backwards and forwards. So as you get the invaders, they speed up at the way that they march across the screen, and the very last invader on a particular level goes incredibly quickly, and it can be quite challenging just to get that last invader. And so the further that you are in the levels, the lower they get, and so the last invader, you get less and less time to get the last invaders as it gets lower down the screen. So the second ROM set to demonstrate is the Alien Invasion. So I'll go through them the order they are in the selection box here, and it starts off and it looks exactly like Space Invaders, only they have their own title screen. I don't know how these companies did it, whether or not they basically stole the ROM sets and reverse engineered them and made their own version of it, or whether it's an officially licensed game. But just going through the track screens here, so the track screens are basically the same. They've changed some of the graphics, like those houses are different, but the demonstration is the same, and it'll play through the demonstration until the base gets hit. And you can see that the base also fires a small dot rather than a longer missile, which was in the Space Invaders. So on here, the dip switch is clearly slightly different. So it says 2 coins for a game, and the scoring display is different as well. So what I'll do is I'll put a credit in. So it says I need to put two coins in as well, and you can see the Y is upside down on the play again. So the alien should come on the screen and correct the Y like it does on the first version. So if I put in a coin, it gives me 1 credit, and there's a little dash next to the O at the bottom, the 0 credits at the bottom of the screen, until I press it again, and now I've got 1 credit, and I can start a game of Space Invaders. And so this is basically the same as Space Invaders Part 2, I think. So they ripped off the Part 2 ROM set. And it plays very much like the Space Invaders Part 1 until I think you get to level 2, then it varies the gameplay a bit. Okay, so I'm about to finish the level on this version. And in this version, when the flying saucers come across the top of the display, they can actually drop a missile on you as well, which is rather a nasty missile. So at the end of the level, it just comes up with the word good, and then proceeds to the next level. So the next ROM to actually look at is Earth Invasion. So this is another kind of a bootleg version of the game, and again it looks like the last one, but again they've just customized the display themselves for their own title. And this is like Space Invaders Part 2 as well, so they've kind of ripped off that version of the game. And they've again changed the graphics on it to make it look different. So if I start this game by giving it credit and then pressing play 1, so again it kind of plays the same as the other one. Although I think on this one, when it gets to level 2, it's slightly different. So just come up to the end of the level on this version. And on this version, the flying saucers also drop a missile as well as they cross the top of the display. So this superior invaders coming is actually a reference to what happens in Space Invaders Part 2, in that when you shoot some of them, what they do is they reproduce themselves, which should happen relatively quickly, I think. I think it happens especially if there's a gap on each side of a particular invader. There, no, not yet, it isn't. There's one that's just reproducing now. Okay, so the next one is the official Space Invaders Part 2. So this is kind of like the ones that I've just been through, which were the bootleg versions. And it comes up with a graphic saying that it's Space Invaders Part 2. I'll give it credit and go into the game. So they come down from the top. Now that bit where they come down from the top, and also when they get to the end of the row and go down, they use a special bit of hardware in the actual machine itself, which isn't part of the CPU. Because apparently, so this was done with an 8080 CPU rather than Z80, which later arcade machines used. And Z80 has shift registers instructions, which you can use, and apparently the 8080 didn't. So what they did was they implemented a shift register in hardware, so they could get the invaders to scroll down the display when they enter the display, and also when they change at the end of the row and go down a row. And in this version of the game, some of the flying saucers that go across the top are actually flashing, which makes it harder to get them, because when they're in their kind of cloaked mode where they're not visible on the display, they're harder to get. And at the end of the level, it just one of them escapes on top of the flying saucer and goes up on top of the screen, and they come back down on the screen again in the next wave. And also on the buildings, it shows which level you're on. So in the first Space Invaders, you didn't really get much of an idea of what level you were on, but it shows as you go up the levels on Space Invaders Part 2 which level you are written on actual buildings themselves. Okay, so the next ROM is Space Invaders Deluxe. Now, when you start this up, it comes up with the same Space Invaders Part 2 on it. So the basis of it is Space Invaders Part 2, but actually there's a bit more to Space Invaders Deluxe than was in Space Invaders Part 2. So I think in Space Invaders Deluxe is where they actually put a colour filter on the CRT display to give the colour banding like I'm emulating here. I think you could probably buy the filters for previous versions of the game as well, but I think it came out of the factory with the filters on the Space Invaders Deluxe machines. So just coming up to the end of the first level. And on the second level, again, it's going to be very similar to Space Invaders Part 2. If I can get there. Phew. So yeah, the escape's on the top of a flying saucer. And it comes into level 2, and there's, on this one, which you didn't get on Part 2, there's a few gaps in the Space Invaders on the display. And also, like the bootleg version of the game, some of the Space Invaders will reproduce. So let's see if that happens at some point. There, so that one just reproduced into 2 new Space Invaders where there's like a gap. And again, it did it, so it makes it a bit more challenging. So the final ROM set, I think. Yeah, because the bottom one is the first one I played. So this is the final ROM set, which is Invaders Revenge, which was kind of a bit different game to the other games. And it has a very different kind of title screen as well. I'll credit and start playing the game. And it takes a bit of a while to actually start the game because it's playing a tune in the background here. And I haven't implemented the sound on these yet either. But as you can see, it's a very different kind of concept to the game. The characters are obviously the same, although the base looks different. And there's an energy bar at the bottom, and they try and steal the bits from the energy bar. And you've got to try and maintain how much fuel you have, which is what the energy bar is. But they can blow up bits, and they come down and steal bits. And when you shoot them, sometimes they can kind of fall down and headbutt you, and that will kill you as well. When I was buying some of these arcade machines in the early 2000s, so there was one falling down once I shot it, I bought a machine which wasn't working, and it turned out to be this when I repaired it. I wasn't really that keen on the game at the time. It's grown on me a bit more now. But what you can do with these machines is, because like you can see on the emulator, you can just change the ROM sets back to the original Space Invaders and convert them back. So I'll go for the source code for the emulator. There's not actually that much source code for the actual emulator itself. Just a quick brief overview of the Z80 emulator. So when I actually run any of my emulators, the principle I have is to give control to the CPU, and then the CPU does callbacks to the actual main emulator. So here you can see every clock cycle it does a callback to whatever the function is that's been registered to call back for a clock cycle. And that way the actual emulator can do whatever it needs to do every clock cycle. And then on the Z80 there's also uses I/O ports, so every time the actual CPU does an instruction for an I/O port, it can call back to the emulator and say, okay, this is like an input instruction or this is an output instruction, and then the emulator can react how it needs to actually emulate the response to an IO instruction. And the Z80 emulation itself, it's just a big loop, and every loop it does a clock cycle callback, and then it decides what the next opcode is that it needs to emulate, and it's a big case statement here. Now there are emulators which emulate CPUs and they do microcode emulation. So in other words, if this is a machine code cycle and the instruction is 0, each bit of that instruction represents an operation to do to actually complete that instruction. So an opcode for 01 will do a different set of microcode stuff, but if you emulate to that level, you end up doing function calls a lot, and that slows down the actual emulation process, because so for this, in the case of Z80, if you're emulating at 4 megahertz, then basically you do an instruction every 4 clock cycles, roughly speaking, and that's like 1 million calls in a second. And if you're doing that and you're doing a lot of calls to actually service an instruction, then that's quite heavy on the CPU. Now modern day computers can handle that, but if you want to run on microcontrollers and things like that, which aren't quite as powerful, it can really impact performance. So in here, for every opcode, I have a set of instructions which I execute, but I don't actually do any call outs to other routines or anything. Each opcode is handled within the small amount of code for each operation. And that means I can actually run on things like microcontrollers, and they don't have to be that powerful. So like I say, each opcode, so this is not opcode, which doesn't do anything, but I record how many clock cycles it uses to operate, and then I increase the program counter, and I go for another Z80 cycle, which is actually goes back up the top and falls back down and does the next opcode. It picks out the next opcode to do, and it could be any opcode. So because on the Z80 it's not a RISC processor, so it actually has, I think, a little bit over 500 instructions. So this is quite a big file in that each instruction is handled in discretely. But like I say, when you look at this code, you won't see any call outs to other functions during these operations. They're just little bits of code for each instruction, and each instruction's pretty much when the CPU does something, most of the time it's just moving memory about, or reading memory, doing a arithmetic operation on it, putting it back into a memory. It doesn't do much more than that. So because I've done quite a few emulators now, if you look back through my videos, you'll see emulators on a number of retro computers. And I've still got some more that I'd like to do in the future as well. I'm basically only doing Z80 and 6502. I've done the Apple emulator for the 6502. I've also done a PET one. I haven't done the video for the PET one yet. And they're the two 6502 ones which I've emulated. But there's a couple of other ones that I'd like to do. So the VIC-20 actually isn't that much more complicated by the look of it than the PET. So I'd like to do like VIC-20 and then maybe do Commodore 64. I don't know. But because I've got all of these emulated systems all run off the same emulator, and the difference between them actually running the emulator is a config file. So here's my configuration file for Space Invaders, and there's not that much you have to configure for the differences between retro computers or actually arcade machines. So because this arcade machine runs on an 8080 CPU, which is basically the same as a Z80, because Z80 is more advanced than the 8080 and it's backward compatible with 8080 code, so you can actually run the Space Invader ROMs on the Z80 CPU without having any issues at all, by configure things like system differences. So in the emulator menu you can actually select different configurations for systems. It's only the computers, things like the Sinclair Spectrum, you'd have a 16K and a 48K configuration. In this particular one for the Space Invaders, you can have a monochrome or a color option that you can switch between, so you can actually emulate from the same code, but just switching small differences in the actual emulation itself. And then I configure how the display is set up, and in the Space Invaders system, it's different to the way I've done computer systems prior to this, because computer systems tend to be landscape orientation, whereas these early arcade machines, a lot of them tended to be portrait, so they're higher than they are wide. So here you can see on the X pixels, there's fewer pixels in the X orientation than there are in the Y orientation, so that's different. And I've had to actually add to my emulation because it's done vertically for Space Invaders and for Galaxians, which I've also done. You need to plot the actual pixels going vertically. The scan lines go vertically. So all they've done is turn the orientation of the tube on the cathode ray to be vertical. So now it scans downwards rather than acrosswards. But didn't need actually that much changing to do for my emulator. I only need to add an extra function to do actually that. And then I go for there's not actually that much to do with configuration here because a lot of it isn't used. So this, where I actually on a retro computer, I can actually give it a text file and type in the text file for itself. Well, there isn't a keyboard on a Space Invaders machine, so I don't need to do that. I've got colors for the display where it emulates the filter, the light filter over the top of a cathode ray tube. So it's not really actually having to change output colors itself from the actual circuit board itself. These are just like implied colors over the top in this particular case. And then for the inputs, so because the inputs on a arcade machine are basically switches to do with player 1 controls, player 2 controls, operations like starting a 1-player game, 2-player game, inserting a coin. There's a tilt operation, so if someone knocks the arcade machine or tries to like fix it, it will actually say, oh, the player's tilted it, and it will reboot the machine. And then there's dip switch options as well, so I've got those as inputs as well. So this is what would be a keyboard in a retro computer, and I've just laid them out in a matrix, even though they're not in a matrix, so that I can actually configure buttons on the keyboard when I'm emulating to actually feed back into the emulator itself. And we'll see that as we go through the actual code for the emulator. And this is just done in the same way as I would do for a retro computer, so I've not had to change any way that I'm doing this configuration, and the rest of the configuration is quite bare compared to doing an actual computer configuration. So this is the actual code itself to do the emulation. It's one file of C to actually do the whole Space Invaders emulation, and there's not that much to it. And if you look back in my previous videos for emulating stuff, all the retro computers, they don't require that much code to actually emulate them. They're very simple systems. At the top I've got global variables which are to do with the emulator itself, to do with like reading a keyboard and things, and getting access to the configuration file which we just went over just now. And then I've got some stuff to do with accessing stuff to do for the actual emulator. So I can access clock cycle count if I need to, so that I can do timing within the emulation itself to the clock cycle level. I can access the memory directly itself. Now the CPU does all the access to the memory, but when you're actually displaying the memory map for a frame of the video display, and if it's in sort of memory mapped out rather than like a character ROM, then you need access to the CPU memory as well. And then I've got stuff for debugging in there. And then these are the global variables for the actual emulation of this Space Invaders PCB itself. So the PCB has a watchdog timer. So if the actual code for the Space Invaders emulation doesn't output to a particular port every period of time, then the hardware itself will reset the board. So I guess when the actual Space Invaders cabinet was out in like a pub or in an arcade, rather than have a system which had a bug in it and it would freeze up and no one could play it, if there was a bug in the code and at any time the actual machine froze up, the watchdog appeared, the hardware watchdog would say, okay, let's reboot the machine, and at least it would get it going again so that people could continue playing it. There's also dip switches on the PCB, which I'm just keeping the value of them there. And then I'm keeping track of keys which have been pressed, so that I can use them in various areas of the I/O configuration as well. And the Space Invaders machine has a shift register to do the vertical scrolling of the characters. So I have to emulate doing the vertical scrolling, but that's the only really bit of hardware that's custom on the Space Invaders machine. And I keep track of whether the configuration has been selected to be monochrome or color as well. So this is the start of the emulation. So the main routine that you have in every C program, and I also have an individual main routine. So if it's just a single executable that I'm compiling, it uses this as the main routine, but I can combine these into a single application as well. So if I was emulating on a Raspberry Pi Pico, I can just add this and it would ignore this main routine. The Pico would have its own main routine, but it could actually start off each individual emulation by going into the specific main routine for that emulation. It makes it just like so that I don't have to have two sets of code. I can just compile everything and just have a definition which says whether or not it's a single execution or a combined execution in one of many emulators. So when it actually starts up, it just gets hold of the configuration for this particular emulation, so that it can do, it can read the specific emulation that is running at this time. It initializes display, so it will just create a window on the Linux machine. You can actually run it on Linux on a Raspberry Pi, which is ARM based Linux, or you can run it on Linux on an Intel version of the machine, so you can actually compile it for that, and it doesn't require any changes to the code to do that. Initializes the Z80 CPU. It says what is the default ROM name which I'm running, because you can see, as you've seen when I ran it, you can actually run different versions of ROMs, and so I had a set of about 10 ROMs for this particular emulation. But when you're running things like the Apple II, that has various versions of the Apple II ROMs which you can actually run as well, so you can select those in the actual configuration of the emulator. But I don't actually load the ROMs at this point. If you look at previous videos, that's one of the things which I've changed in the emulation, whereas I would normally just load a set of ROMs at this point, but I don't do that anymore, so that I can actually select whichever ROMs I want while it's running. Then I set up the callbacks. So this is how the actual emulator is going to work. So I've got a function in this software which is for the clock. I've got a function where when the Z80's CPU is reset, it calls back into this code so I can emulate what happens with the real hardware when the reset occurs. And then I've got these ports as well. So these are the ports for the Space Invaders. These are Z80 ports. So I haven't called them anything special. Because each port can do a number of things kind of generically, they don't have a specific function themselves, so I kept the name as generic as well, so as not to imply that they only do a specific task. But there's not that many ports it actually uses. It only uses 7 ports there, and one of them it doesn't really use. So and then I just clear the display before I start executing the emulator. I give control over now to the Z80 emulation, and it runs the emulation and does callbacks to the functions which I've registered up here, and that's the emulation running. And then once the actual emulator finishes, it terminates the Z80 emulation and exits back to the Linux operating system. So first thing that happens in the emulation is the Z80 will reset, and at this point I load whichever ROM set has been selected. That way in the configuration for the actual emulator, if someone goes into the configuration menu, changes the ROM and then does a reset, it will automatically load up that ROM set and execute that. I've kept notes of where the actual ROMs for the Space Invaders go in memory. This is the memory map which will get loaded up when you load up a ROM set. And then this is the RAM memory layout. So it's got some game RAM, which I think is about 2K, and some display RAM where it's got a memory mapped display, and that's about 2K as well. And it's only monochrome display, and each byte in the display is 8 pixels of monochrome information. And then I write protect the rest of the memory. Now I don't have to do that. I could just say I'll give it full RAM, but actually to actually simulate what the actual machine itself does, I might as well write protect it so that if it tries to write outside of RAM, it won't succeed in writing outside of RAM. But if I were to comment that line out, it would make no difference to the execution at all. And then on the reset, I say, okay, is the color enabled or not for this configuration? And if it's enabled, I set it to true, so that when it comes to display in the actual display, I can decide whether or not I want to actually display color or not. Then I get to the callbacks for each of the ports. So I registered these callbacks up in the initialization, and when the Z80 gets an IO operation on port 0, it will call into this port, and I can decide whether or not it's an input or an output. On this particular port, you only have inputs. I've made notes of what each bit of the data bus is for this particular port. Now this port doesn't actually get called from the code, but it's on the actual hardware, so I thought, well, I'll include it anyway. That way if it gets called, I can actually do something with it. Then we come down to some of the ports which do get actually called. So port 1, and that configures, that handles this on the input side. So if a coin is actually inserted, then bit 0 will be a 1, or if start a two-player game is button is pressed, then it will set this bit. One player is pressed, then do that bit, and it also does controls for player 1 as well on this port. And so all I have to do is I say, okay, is it an input, and if it is, then has the key been pressed for a coin operation? If it has, then set bit 1, which is the coin operation I've listed. This is the actual bit, which is bit 0, but it has the value of the first bit being set, so that was a bit confusing. And then if start two-player game has been set, then return this bit being set, and that's the result being returned back from the call routine. So the Z80 emulation then knows that that's been those bits have been set or not, and it can operate accordingly. Then the next port is another input port, and also it performs hardware shift register stuff. So the actual input port bits do this, so you can see it does the player 2 controls in this particular case, or if the tilt switch has been activated in the actual arcade machine, and it performs whatever needs to be done for those operations. So this is what happens if tilt's been set. A key is, so I've actually assigned a key press on the keyboard, so that if I want to see what happens when the tilt operation goes, then I press, I think it was key 9 I've allocated to that. But on an output, so that's on the inputs, but on the output it reads the shift register stuff, so it actually performs a hardware shift register shift, or it actually sets the shift, how many bits it needs to be shifted by, I think. And then the next port is to do with audio output. Now I haven't implemented the audio on this yet, so in here you'll see that there isn't anything on the output, but when it does a hardware shift register read, it actually returns the shift register value shifted by the number of bits that have been registered to be shifted by, and it has to do it that way, so it doesn't do the shift up here, it just registers how many bits it needs to be shifted by, and then it does the actual shift when it reads the shift register. And to actually load the value into the shift register, it does it on port 4, and it's the shift register is 16 bits, but a port output can only do 8 bits at a time because the data bus is 8 bits, so it actually does 2 writes to the shift register value. So it does 2 outputs on this port to actually load up a 16-bit value into the shift register, so that's what that does. And then port 5 is again outputs for audio, which I haven't implemented. I'd like to implement those later. I think a lot of emulators do samples of sounds and just play samples of sounds, but I'd like to actually try and emulate what the hardware is actually doing for the sound, and see if we can get authentic sound by doing that, but I don't know how easy that would be. Then port 6 is the hardware watchdog. So when so the actual code in the Space Invaders ROMs needs to update a hardware timer, and it needs to clear the value in the hardware timer periodically. But if it doesn't clear the timer, then the hardware will, after a period of time, the timer will overflow and it will reset, form a CPU reset on the machine. So this is where the actual code actually resets the watchdog timer. And this is the actual bit where the actual emulation goes on. So for every clock cycle of the actual hardware, these operations are performed. So there's interrupt on the 8080, but there's only one mode of interrupt, whereas on the Z80 there's 3 modes of interrupt. But mode 0 is the one which is compatible with the 8080 CPU. So when you boot the Z80, it goes into mode 0 anyway for compatibility's sake. So I don't actually have to do anything to make it compatible. It will just be compatible when the Z80 comes up from reset. And the actual interrupts which occur on the 8080 is when an interrupt occurs, the 8080 will read the next what's on the data bus, and that will be the next instruction to execute. And on Z80s and 8080s, there's this RST instruction which says call a routine, and it's just an 8-bit value. And that 8-bit value is the lower address bus, and the upper address bus is assumed to be 0. So it will call address 0008, and there's 2 different interrupts which occur on Space Invaders machine, that one and 00010, and they occur alternately. So half of the display refresh cycle, it will call the first interrupt, and for the second half of the display interrupt cycle, it will call the second one. And that's all it does here. I have implemented interrupts by registering what instruction needs to be executed for this particular mode. Like I say, if you look at the Z80 emulations I've done for other computers, they tend to be in mode 2 or mode 1. They don't tend to use this mode 0. So you'll see how I've implemented those different modes if you look at the other emulations I've done. And then this is a frame of the actual video display. So this occurs every 50 Hertz, because I've always assumed 50 Hertz for doing emulations in the UK, but you could change it to be 60 Hertz as well if you needed to do 60 Hertz emulation. And what the hardware does is it says, okay, has the watchdog period overflowed? So if it gets down to 0 when it's decremented, then I'll just output to my console that a watchdog resets occurred, so that it makes sense that the machine is actually resetting, and it's not something which is happening in code, because this should never happen, and I have not seen it happen, because code shouldn't have any bugs in, and I don't believe there are any bugs in it. So, but I've put this in to emulate anyway, so if code ever occurs where there's a bug and it hangs the machine, then this should reset the machine itself. Then I read the keyboard on the actual computer, and I put keyboard input for playing, like left, right and fire for player 1 and player 2 into this variable, and key operation inputs like start player 1, start player 2, tilt, service mode, they go into this variable, and then the actual dip switch values for the inputs go into this particular variable, so that I can handle that throughout the operation of the emulation. And I handle the key dip switches here. So if a press has been happened for a key dip switch, I use function keys F1 to F8 on the Space Invaders one. It comes into this loop and it just displays on the display what the bits are currently switched to, and it allows you to actually press function keys and change the dip switch values depending on which function keys have been pressed. I've done that here rather than the emulation code, because even though a lot of machines have dip switch values, they're not always handled the same. So in the case of Space Invaders, it's got 8 bits of dip switch values, but on the Galaxian machines it only has 6 dip switch values which can be set, and on other arcade machines you can have 16 bits and stuff. So rather than try and handle that globally in the emulator, I'm doing that as a custom thing in the actual emulation code for each particular machine which I'm going to emulate. And that makes sense anyway, because it is hardware related, the dip switches, so it makes actually sense to do that here. And then the only thing left to do is actually update the display of the Space Invaders machine. So I'm pointing first of all to the very end of display memory, and I'm going through the scan lines and scanning along each line, and I'm getting each byte for each part of the display memory. And after I've got that, I'm pointing to the next byte in the display memory, so next time it comes around this loop, it'll go do the next byte of the display memory. And all it's doing is this function just plots out 8 pixels out of 1 byte. So for each bit in each byte, there's just a monochrome, either the pixel is on or it's off. So that's all that this does. It loops around the byte 8 times and plots on the window of this emulation 8 pixels, and it will do that until it's done a complete line of the raster, and then it will do that for every line of the raster. So it just plots out the whole display, and then after it's done that, it says okay, now output that plot to the actual window for Linux. Or if it's doing it on a microcontroller like the Pico, then it will output it to the hardware display on the Pico microcontroller. And that is all there is to the code for the Space Invaders emulation.